good morning, good afternoon, good evening, depend on where and when you are watching this video. How you guys doing? I hope you are doing very fine. I wish you a wonderful day. Yeah, in this video, allow me first and foremost welcome you all. We'll be talking about fractions. In fractions we have proper fractions, improper fractions, mixed fractions, and the rest, two of us. Yeah, we will look at them and solve some examples. Is that clear? Okay. Let's consider the topic fraction. Today's topic is fraction. Fractions. Okay. Yeah. I know very well that some of you are not familiar with the word fraction. What do you mean, or do I mean by fraction? I'm going to explain it down in details for you, step by step. Yes. What if I may refer you to those of you who knows how to cook very well, both men and women. And you know that in the kitchen you make use of mathematics. Yeah. Some of you ask yourself, yes, I came to study catering in the university. I came to study food tech and the rest. Why is it that we are doing mathematics? Well, you've forgotten that all you're doing, both in real life and whatever thing you are doing, you are applying mathematics. Okay, let's use a real life problem as those of you who normally cook in the kitchen. If, okay, look at it. When we say fraction, some persons, if they want to cook, depend on the measure of the food or the soup that you want to cook. Two of us. Even if stew, you want to prepare stew. Two of us. Yeah, some persons, if they want to cook, let us have the onions in this shape. Amen? Yeah. If they want to cook, they will now divide this onion, two of us, into parts. They either make use of this. They make use of these parts. You know that fraction is also known as parts. You have parted it into how many places? Two of us. So you discover that you want to reserve this other side. You want to reserve this other side. This side. Then you want to make use of it. This is what we call fraction. So in the kitchen, you make use of mathematics. The mathematics known as what? Fraction. Is that clear? Do you get me? Do you understand? That is what you do. Okay. So that is that. Then this is onion. What of mangi? Let us have a mangi of this one. Some persons, they don't use the full mangi itself. They either part it this way, two of us, or the pattern will now be this form, true or false. It means if you part it, we are going to have it this way. You have used this side, remainder here. If you part it, it means you have used this side, remainder here. So this is what we call fraction. Amen? Fraction. So we are going to look at in fraction. We'll look at proper fraction. Proper fraction. We'll look at proper fraction. Proper fractions. Okay. When we say proper fractions are of this form. 1 all over 2, 3 all over 5, 4 all over 7, 5 all over 12, etc. We call them proper fractions. Why? Because, you know, when we have something of this form, we call this numerator. This is numerator. Why this is called denominator? Take note. So the reason why it is called a proper fraction is the numerator is always lesser than the denominator. That is, the denominator will always be greater than the numerator. So it is known as what? Proper fraction. So if I may ask, is this a proper fraction? No. This can never be proper fraction. Why? Because the numerator is greater than the denominator. So, and this is called improper fraction. Are you following? Do you understand? Okay. So far so good. We are going to somewhere. Yeah. Let us have okay. Let's have drawing here. Okay. I want to do something. Let's have it here. Let's have 1, 2, 3, 4. We have 1, 2, 3, 4, 5, isn't it? Okay, let's shade. Let's shade. Let us shade this thing. Okay. So if we want to interpret this container, or if we want to interpret this container, we discover that we have how many rooms? 1, 2, 3, 4, 5. Out of the 5, 4 are shaded, true or false. So if we want to interpret it in fraction, it means this is known as 1 all over 5. Do you agree with me? Then, what if we claim one of these? The reason why it is 1 all over 5, out of 5 we shaded 4, we did not shade 1. So now out of 4, 3 are shaded, true or false. So how are you going to interpret this one now? This one will now 2 all over what? 5. So you discover that this is what? A proper fraction. True or false? Huh? It's a proper fraction. It's a proper fraction. Yeah. So that is that. Yeah. So let's do some examples in proper fraction. Example. Simplify or evaluate, whichever way, whichever one you see. 3 all over 5 plus 4 all over 7. This is simple as ABC. Is that clear? You know very well that we write solution. Amen. Our 3 all over 5 plus 4 all over 7. If you come across questions like this, what you first consider, you know that these questions are fractions, true or false. And when you look at the fraction, proper fraction, why? Because the numerator is lesser than what? The denominator, isn't it? So for you to simplify this, look at this value here and look at this. You look for the LCM, their LCM. What can you use to divide 5 and 7 and without a remainder? But the first way to approach this kind of problem is use this 7 to multiply this 3, use this 5 to multiply this 4, then use 5 to multiply 7. You've gotten your LCM. So in case we want to bypass time, let's do it. 7 times 3, 7 times 3, what do we have here? Plus 5 times 4. Then all over 5 times 7. Yeah. So this will now be equals to 7 times 3, 21, plus 5 times 4, 20, all over 5 times 7 is going to give you what? 35. So by the time you sum the numerator, 21 plus 20 is going to give you 41 all over 35. So this is the answer. This is how you are going to do it. Okay. Any question? Yeah, I don't think you will have question for now. Yeah. So that is proper fraction. In addition, so let's consider proper fraction, a subtraction. Yeah. Can I clean this? Okay. So let us convert this one to minus. It's the same approach, just that the sign changed. It's the same approach. So what you need to do is the same way. You must look for the LCM. Okay, the other one we multiply it like this. We can still do the same thing, but let us use another approach so that you understand both of them. Ask yourself, what can you use to divide 5 and 7 without a remainder? 35, true or false? 35 times 7, oh sorry, 5 times 7 will give you 35, isn't it? So you write 35, then 35 divides 5, 7. So 7 times 3. You can now see. So what do we have here? Minus 35 divides 7, 5. So 5 times 4. So here will now be equals to 21 minus 20 all over 35. Amen? Do you agree with me? Then this is the same thing as 21 minus 20 is going to give us 1 all over 35. Yeah. Is it difficult? No. I don't think it's difficult. Okay. Yeah. So this is how you are going to approach it. Okay, what if it is multiplication? Let's consider, let's change this one to multiplication. Times. Amen. Okay. Yeah. If it is multiplication, 3 all over 5 times 4 all over 7. If it is multiplication in between them, you don't need to look for the LCM. What you need to do, this is numerator, this is numerator, two of us. Use this numerator to multiply this numerator, then use this denominator to multiply this denominator. That is the final answer. That is, this is equals to 3 times 4 all over 5 times 7. Then equals to 3 times 4 is going to give you what? 12. Then 5 times 7 all over what? 35. Is it difficult? Huh? Is it difficult? Okay. Yeah. You know, sometimes you may not see this place as what? Multiplication. Instead of that, you may see 3 all over 5 of 4 all over 7. It means in mathematics, when you see off, this is the same thing as multiplication. So take note. So you are going to what? Transform it this way, and at the end of the day, you will see arrive at what? The same answer. That is, what do I mean? That is this 3 all over 5 of 4 all over 7 is the same thing as 3 all over 5 times 4 all over 7. Then this is equals to 3 times what we did here is the same thing times 4 all over 5 times 7. Then equals to what? This is equals to 12 all over 35. So this is how you are going to approach it. Is that clear? Do you understand? Okay. So now that is a proper fraction for you. So let us let us consider improper fractions. Amen? Okay? Let's consider improper fractions. Improper fractions. Improper fractions. Okay, yeah. Let's look at it together. Can I clean this? Okay. It's simple as ABC. Amen. Yeah. We are able to learn and understand proper fraction. Let me repeat it all over again. When we say proper fraction means the numerator is always lesser than the denominator, that is 1 all over 2. You see that 1 is lesser than the denominator. The denominator is always greater than. Yeah, that is proper fraction. Now, we want to consider improper fraction. The improper fraction means the numerator is always greater than the denominator. That is 3 all over 2. This is improper fraction. You see that the numerator is greater than 5 all over 3. Yeah, is an example. Then 4 all over 3. This one too is an example. 10 all over 7 is an example of what? Improper fraction. Why? Because this is the numerator. Amen. The numerator is always greater than the denominator. Amen. Yeah. Okay. Yeah. So this is called an improper fraction. Amen. Yeah. Okay. So let's look at one example. Evaluate. Amen. Evaluate 5 all over 3 plus, let's start with plus 10 all over 7. It's simple as ABC. Yeah, we write solution. Amen. Solution. Our 5 all over 3 plus 10 all over 7. Yeah, this implies that it's the same approach. The way we solved proper fraction is the same way. We can now go for the LCM. Either use this one to multiply, this one to multiply, whichever way you want to do it. So which one do you want? Okay, 5 times 7. What do we have here? Plus 10 times 3 all over 3 times 7. Yeah, that is 7 multiplies 5 plus 3 multiply 10, then all over 3 times 7. Okay, so here 5 times 7 is going to give us 35, then plus 10 times 3 is 30 all over 3 times 7, 21. Amen. I hope you are following. Okay, you agree with me? Then 35 plus amen, 35 plus 30 is going to give us 65 all over 21. This is the final answer. This is how you are going to approach it. So when you look at this expression, you know that the expression is an improper fraction, true or false? Why? Because both the numerator of this is greater than the denominator, and even this one too is greater than. But there are some that you will see both, maybe this one you will see proper fraction, then this other side you will see improper fraction. Yes, improper fraction. It's the same approach you will use to solve this. So even if it is minus, if you turn it to minus, it's the same way. It implies that okay, let's take 21 to 3, 7 times either 7 times 5. What do you have here? Minus 7. 21 to 7, 3. 10 times 3. This is equals to 35 minus 30. Amen. All over 21. So 35 minus 30 is going to give you what? 5. 5 all over 21. Is that clear? But if they convert here to be times, it's the same way which we have done it before. True or false? Okay. So that is that. It means I use this one to like 5 all over 3 times 10 all over 7. This is equals to 5 times 10, numerator to multiply numerator, all over denominator to multiply denominator. Then you discover that at the end of the day, you are going to have 50 all over 21. Yeah. Any question? Okay. So we are moving forward. So even if here you see off, you still convert it like this. It's the same answer you will still get. Is that clear? Okay. Yeah. So which other one? Let's consider mixed fractions. Amen. Mixed fractions. Mixed fractions. So I can claim this, right? Let's consider mixed fractions. Okay. Mixed fractions. Mixed fraction. So you need to know this, then we now go deep to solve one or two examples. Is that clear? So mixed fractions. Mixed, amen? Mixed fractions. Okay, when we say mixed fractions are of this form. It is either 1 whole number 1 all over 3 or 2 whole number 1 all over 5 or 3 whole number 2 all over 7 or 1 whole number 4 all over 5. Yeah. If you come across values of this form, fractions of this form, it is known as what? Mixed fraction. Is that clear? Mixed fraction. We convert mixed fraction to proper fractions. We convert mixed fractions to improper fraction. Okay, like let's look at it. Let's look at it and let us identify. Sometimes you may see convert the following to either proper or improper fractions. Okay, how can you convert 1 whole number 1 all over 3? This is equals to, use this denominator to multiply whatever that is here. What is here? 1. Then add it to whatever that is here. So 3 times 1 is 3 plus 1 here, 4. So it will now be 4 all over 3. So what is the name of this fraction? The name of this fraction is what? An improper fraction. True or false? Why? Because the numerator is greater than what? The denominator. Okay, let's try another one. Let's try another one. Okay, let's try this one again. 2 whole number 1 all over 5. You use this 5 to multiply whatever that is here. 5 times 2, 10. 10 plus 1 is going to give you 11. So 11 all over what? 5. So what type of fraction is this? An improper fraction. True or false? Because the denominator is lesser than the numerator. Okay? Do you agree with me? So if you agree with me, so far so good. So now we have come to know mixed fractions, proper fractions, and improper fractions. So now let us, there are some questions that you will see, both mixed fractions, proper fractions, and improper fractions. But before we solve questions that involve that, let us look at addition of mixed fraction. That simplify, let's say 2 whole number 1 all over 5 plus 3 whole number 2 all over 7. Yeah, it's simple as ABC. If you come across questions of this form, what you need to do, you write solution. Is that clear? Don't rush. You write 2 whole number 1 all over 5 plus 3 whole number 2 all over 7. So, you know, you must convert this and this to what? Improper fractions before you can be able to what? Solve this expression. Do you agree with me? Take note. So, as it is, you cannot solve it, but you must convert it. So let us convert it first. 5 times 2, 10 plus 1, 11 all over 5. True or false? Then what we have here, plus 7 times 3 is 21, plus 2, 23 all over what? 7. So now we go for LCM, isn't it? We look for LCM, or the other way around. We just do the other way around. That is this one multiply 11, 7 multiply 11, 5 multiply 23. Is that clear? To save time. Is that clear? Okay, so the denominator will now be 5 times 7. Then the numerator will now be 7 times 11 times plus 23 times what? 5. So this one will going to give us 77, true or false? Then 23 times 5, 3 times 5, 15, isn't it? Carry 1, write 5, 10, 11, 115. Is that clear? So 77 plus 115 all over 35. Amen. This is equals to 77 plus 115. This one will going to give us 12, carry 1. So this 2 plus 7, 9, 1, isn't it? So 192 all over 35. So this is how you are going to simplify this type of problems. Is that clear? Okay. Yeah. So let's consider minus. If here is minus, subtraction, sorry. If here is minus, it is the same approach. It means here will be minus, isn't it? Here will be minus. So it implies that this one times this give us 77. This one times this give us 1. So here will be minus, isn't it? So this implies that okay, let's just do it this way. Minus 1, it cannot 5 cannot subtract 7. We borrow 1 from here. 10 plus 5, 15, isn't it? So here we're going to give us what? 8. Here is 0, right? Borrow 1. This is 10. 10 plus 10 minus 7 is going to give you what? 3, isn't it? So it means 38 plus 77. So we'll give you back this, true or false. Here is what? Here we're going to give us 15. Carry 1 to this 1, 1, yes. So here we're going to give us minus 38 all over 35 if it is negative. Is that clear? Okay. So I will solve some problems. We'll look at some problems here. Okay. So let's solve a problem that contains both proper fractions, improper fractions, mixed fractions, and the rest. Okay, so evaluate, amen, evaluate two whole number, 1 all over 3, then of 1 all over 4 plus 5 all over 3. Yeah. You can now see that this expression, this fraction contains both mixed fraction, proper fraction, and what? Improper fraction. Okay? So let's write solution. 2 whole number 1 all over 3 of 1 all over 4 plus 5 all over 3. Amen? Yeah. We must convert this to what? Improper fraction. So this is equals to 3 times 2, 6 plus 1, 7 all over 3 of 1 all over 4 plus 5 all over 3. Yeah, at this point, we are going to use what is called board mass. Board mass. Whenever you come across fractions containing mixed fractions, proper fractions, improper fractions, you must make use of what? The board mass. B stands for, let me define board mass for you. B stands for bracket, amen. O stands for off, which is the same thing as times, right? D stands for division, amen. Division. Then M stands for multiplication, amen. Multiplication. Okay. A stands for addition. Take notes.